So good afternoon, guys. How are you? Enjoying BriForum? When you went to get lunch, did you get a plate? After a while. Some of us didn't. So I'd like to ask a couple of questions and do some housekeeping at the start. One of the bits of housekeeping is, as you may have noticed from my accent, I am from the UK, from London. This means I swear. I'm sorry, but I do. So if you're upset or offended by the occasional swear word, then this is not for you. But other than that, please stay. Also, I was like asking this question: is this their first BriForum? Wow, cool. So you enjoying it so far? Nods of heads, yeah, okay. So we're here today to talk about PVS versus MCS. So who's got a Zen desktop deployment right now? Okay, lots of people. Who've only got Zen app and are wondering about this whole MCS thing? Okay, a few people. All right, cool. So my name's Jim Moyle. You can find me on Twitter at Jim Moyle. I've got a blog at jimmoyle.com. I'm also very privileged to be a member of the CTV program, along with a few of the other speakers here this week. I work for Atlantis Computing, which I'm sure you heard Brian mention in the keynote. We've actually got a stand outside, so I'm not going to be talking about Atlantis at all in this session, but if you want to talk to me about that, then come along to the stand and pick up Brian's new book, which if you haven't already done, you can pick up from the stand as well. In London, I did this session with a friend of mine called Aaron Parker. And the alternative in the title is MDT, so Microsoft Deployment Toolkit. I am not an MDT expert. I do the PVS and MCS bit. So it's a real shame that Aaron couldn't be here to do the MDT bit for you. So I'm actually going to try and give you a high-level overview of what he would have talked about if he was here. But if you've got any detailed questions about MDT, I'll write them down and I'll email him. So you can find him at StealthPuppy and stealthpuppy.com. The reason why he calls himself that is less funny than you'd think. And he's also a CTP. And he works at Kelway in the UK. And it's their fault that he couldn't come this week. So blame them. Hey guys. So why is this a pertinent question now? Well, the reason it's a pertinent question is because of Zen Desktop 7. Because previously, this choice between, there's loads of seats, guys, it's all right, just spread out, go on, find seats, it's fine. Can somebody just shut the door if that's okay? Thank you. So previously, this wasn't much of a choice, because if you had any Zen app at all, then you would always use PVS, because there was no MCS for Zen app. And it was only the guys that did pure Zen desktop that even faced this choice. And even if they were had a mix, you would always go PVS, because what's the point in having two provisioning methodologies when you've got when you can only use PVS for Zen app? So when I say Zen Desktop 7 brings MCS to Zen app, that's kind of backwards, because it's actually Zen app has come to MCS, because the IMA architecture, as you guys probably know, is no more. Now it's FMA, so effectively Zen app is being ported into the Zen Desktop architecture, and hence MCS being available for Zen app. So now if you're moving to Zen Desktop 7, this is a choice that now everybody's got to make, instead of that very small percentage of people that it used to be before. So essentially, they're both just deployment methods, right? There's lots of different ways to deploy your VMs. Both Citrix and VMware provide some help in terms of, as we say, MCS PVS link clones. I'm just going to talk about how you should take advantage of both. What are the rumored pitfalls? What are the actual pitfalls? And when you should use each technology. We're also going to touch a little bit on PVD, because I don't think you can talk about deployment in this sort of way without talking a little about Citrix Personal vDisk. So everything's virtual now, right? Some people still run physical XenApp, but it isn't going to be around for very long. So how do you get from physical to virtual? How do you deploy all your VMs? How do you make this journey? And one of the very first things you've got to decide when you're on the road is stateless versus persistent. So just to ensure that we're talking about the same thing, when I refer to stateless versus persistent now, in the industry, there's a ridiculous number of terms for a stateless and a persistent desktop. Pooled, dedicated, non-persistent, stateful, they all kind of mean the same two things. So stateless is a pint of beer. The reason why stateless is a pint of beer is because it will go very quickly and you will never get it back. But there'll be another one just like it along very, very soon. Persistent is a hip flask, because it is both personalized and personal to you. It is something that you want to keep on you and you want to keep having access to over time. You like that, Steve, do you? Yeah. So, in the terms of PVS, MCS, stateless and persistent. So stateless, provisioning services, machine creation services, link clones. Persistent, full fat VMs and personal vDisk. Citrix would have you, and VMware for that matter, would have you have these three provisioning methods also under here. All right? I don't agree with that at all. And we'll go through the reasons why not as we go through the session. So we're going to talk a little bit about what you need to do before you get to provisioning services, machine creation services. You need an image, right? Now, lots of people will say, well, I've only got to create it once. And you create your golden image, and you do your POC with it, and then you install your applications, and then the rest of your applications, then you update your applications, and there you're golden. You can go on from there. The trouble is that you then need to update that golden image. It means that you're forever unpacking that golden images and making changes to it. Now, in PVS, you get some help with that. You get the image management piece, but you don't get any of that help in MCS or link clones. And when you're unpacking and changing that golden image all the time, you run into a problem. And that problem is that it becomes so that you can't reproduce that golden image. You can't get back to a known good state. So if your 25th change breaks your 5th change, and you just go back and fix application number 5, because that's your workaround, how do you do that? Because you can't uninstall it and into your golden image, and then you've been uninstalling and then reinstalling applications into your golden image and then spreading that all around your environment. You get into terrible trouble. So my view is that you should automate the creation of your golden image. Because once you've automated it, it becomes modular, it becomes scripted, so that you can always, and it doesn't matter what your staffing is or what your documentation is like, you can always push a button and get back to your base image. And you can then change and mess about with that as you wish. And one of the ways you can do this is by using the Microsoft Deployment Toolkit. So it's essentially a grab bag of a set of utilities that Microsoft Microsoft has, and it comes under this umbrella of Microsoft Deployment Toolkit. If you have a Windows Server license, you have access to this. So it's essentially free. And you can actually configure it in two ways. One, it just relies on a file share, and for larger deployments, you can attach it to a SQL server. So what this means is that you can use this free tool, if you haven't got an expensive one, to automate your deployments. Now, you can do PVS MCS and automate your Golden Image deployment, and you can also use it to deploy persistent desktops. So if you are doing full clones and you have that persistent desktop architecture, then you can use MDT as a tool to deploy all this and make sure that everything is as it should be. At this point, Aaron usually steps in and he goes, "Hey Jim, I'm going to start this cool deployment and I'm going to do a live deployment." Unfortunately, as I say, he's not here. So I'm in a bit of trouble, really, aren't I? So I have a small solution to this, and I kind of feel like the teacher when they're doing video day, right? I'll put a film on and I'll go and stand over here. So I've got a very short video of exactly what kind of thing you can do with MDT. Let me try and get this up on the big screen. There we go. So essentially, MDT is a whole load of scripts. It integrates with WDS, etc., etc. So what Aaron's done here is essentially got a PowerShell script. And he's going to take us from essentially nothing and have a working persistent Zen desktop deployment within, and this actually takes about 40 minutes. I'm not going to make you sit through it for 40 minutes. We have speeded some of this up. So if I just try and hit play. So vSphere and Zen desktop inventory before deployment. So there is nothing up my sleeves, essentially. There is no catalog, and there is, I'm going to have to watch this because I can't see it on there. And there is no users assigned to those desktops. So start the scripts and authenticate to vCenter in this case. And what that does is it enables the PowerShell to go and talk to the vCenter, and it's going to create a new VM from a template. You could create the template using PowerShell just from straight, but in the interest of time, we've created one from a template. Connect to MDT and the ini file with all the settings. Now, what we're going to do now is we're going to fill that empty VM template with Windows. And let's say we're starting from absolute scratch here. So this is the bit we've speeded up for you a lot. So it's quite fast anyway. So everybody knows the sysprep settings. So sysprep is just part of MDT, right? It's just a component of MDT. It's not the whole thing. A lot of these scripts Aaron has made public at his blog at stealthpuppy.com. So if you go to Aaron's blog at stealthpuppy.com, you can grab a whole sections of all of these scripts that he's done here, and you can use them for your own MDT deployment. One of the ways that Aaron and his colleagues use this, because he works for a large consulting company, they do it because it relies just on a file share. They can actually transport it into different customers and then deploy exactly the same architecture that they know is correct and finesse to all of their customers.
Sorry, what did you say? You can give a copy of the script?
So stealthpuppy.com, as it sounds, spelt as it sounds. So this is connecting into Atlantis. This project we did together, so Atlantis is part of it. And we've got a fast clone that clones desktops in about 8 to 10 seconds, so it's just doing that from the PowerShell script. And then essentially, it's creating the, registering the VMs and creating the Zen desktop catalog and adding the VMs into that catalog. That's it. So you guys can take this away and either do as Aaron's done and create a whole load of persistent VMs, or you finish it at the point of building one, and then you take that as your golden image, and then you use MCS PVS or link clones to deploy that golden image. So I think that's kind of cute as something that all of us have got access to as a free tool from Microsoft. There we go. Thought it wasn't too long. So sorry for not having the actual expert here today, but there we go. So MDT relies on deployment share, the ini files, WinPE, so you can pixie boot, WDS to deploy the image, and obviously your target PC. I'm not going to go through this slide, but I'm going to leave it there on the PowerPoint, so if you guys want to have a look at the slide later, then you can have a look at all the steps that, that we go through. So why shouldn't you use PVS or MCS for persistent desktops? Even though Citrix says that you can. Well, maintenance, for one. So if your VMs are MCS VMs, there is no such thing as a storage vMotion for an MCS VM. So that means that your diff file that you've created that has all of the changes that the user has made to that operating system is sitting on your bit of storage. If you get rid of that diff file, then you get rid of all the user's changes and they're back to their golden state, their original state. Now, if you've got a persistent VM, this is exactly not the point, right? Because you want those changes to persist. So if you need to perform any maintenance on your underlying storage, you cannot. There is no supported way to move an MCS VM off that storage. You either stay exactly where you are, or you tell your users, you know all those 12 months worth of changes that you've put into your VM? Bye. Growth of delta. So your delta file, your difference file, means that as the user makes changes, as the OS does something like grow and shrink the page file, the way NTFS works is it won't delete the blocks from the storage. It just marks them as able to be overwritten. So that means that these blocks stay around. And the way Windows works is that it will write blocks into free unused space in preference to overwriting stuff. So what will happen is that the delta file will eventually grow to the same size as the disk on your golden image. Not the data, but the disk. So the reason I say it's good for consultants is because you can fit all of these persistent MCS desktops on an SSD, and then you can run away, and 6 months later, everybody's in the shit. So, third one is that you have to use existing update methods. You can only use PVS and MCS once, and that is to deploy that VM. You cannot then use it to update that VM because you break your difference files. So from that point on, you have to not touch your PVS or MCS admin console. And then you have to use SCCM, WSUS, et cetera, to update your VM. So you have to then fall back on all your normal deployment methods and all your normal update methods that you thought you were getting away from by using PVS and MCS. As I said before, there is no vMotion for an MCS desktop. Storage vMotion. Troubleshooting. Well, what you've done is essentially you've split your I/O stream. So you've got reads coming from your golden image, you've got writes going to your Delta file, you've got other stuff going to your PVD if you have it. So if you've got some kind of storage performance issue with VDI, anybody heard of any kind of storage performance issue with VDI? It's kind of a big thing. So if you have one of those issues, then it becomes much more difficult to troubleshoot, because where's your I/O coming from? Where is your latency in that golden image? Plus, maybe you've got desktop guys who aren't conversant in the way that MCS or PVS works. If you've got a full clone, none of these problems happen. DR. DR is much, much more difficult with a stateless provisioning method. Anybody tried to make PVS resilient? Anybody actually made it work? You can do it, but it's a non-trivial exercise. And MCS is difficult as well. So we talked about block size and growth of deltas. So one of the VDI optimizations that you get is this. And some people say that if your file goes into the recycle bin, then obviously you don't lose it, but if you turn off your recycle bin, then they think you lose the file. Well, you don't. And turning off the recycle bin tends to be one of these things you do to optimize your image. There is a reason it's there, right? So, like a load of these, I mean, this is a bit of a digression, but like a load of these optimizations, turning off indexing, turning off the recycle bin, turning off super cache, these are not optimizations. These are cost-saving exercises, all right? Because it costs you in disk performance. I hate the way that this kind of fundamentally changing the user experience is taken as read in the desktop industry. We should not be fundamentally changing the end user experience. So provisioning services. This technology allows computers to be provisioned and re-provisioned in real time from a single shared disk image based on software streaming technology, lifted directly from the Citrix website. So Citrix originally bought this technology from Ardent. Ardent developed it for a physical world. This is pre-virtualization in any real way, certainly pre-desktop virtualization. And you can tell that it's created for a physical world because it doesn't take advantages of any kind of virtualization technology. Because what you've got is you've got SQL databases, AD integration, Pixie services, and the provisioning architecture itself. This, in my opinion, is a very complex thing to achieve what virtualization does very easily, which is create snapshots and new images. Now, anytime I do this, we always have some real big fans of PVS in the audience because people have done it and known it and loved it and trusted it. Any big fan of PVS in the audience? Woo! All right. When it works, it's a great technology. It's a bugger to troubleshoot, though. Actually, Pixie's a bugger to troubleshoot. It's like doing a jigsaw blindfolded. So, my clicker's just gone on the fritz. Is it using PVS? Dave said it. Yeah. There we go. All right. Not only that, here's a list of ports you have to have open for PVS to work. So a lot of people have some interesting architectures around PVS nowadays. I've even seen somebody use a combination of cloud platform and NetScaler to deploy, manage, and make PVS resilient. And they're deploying a single PVS server to every single host, isolating the Pixie on a private VLAN, and then controlling individual DHCP server options to get the IP address of the PVS server to work. And that is a scalable PVS architecture. They do need to. They've got 100,000 XenApp users, so they had to think of something. PVS also gives you some interesting choices for configuration. So you have this in your drop-down list of where you should put your PVS cache. And we'll just have a look at each one of these in turn. Cache on device hard drive, which most of you use and is best practice, all good stuff. Happy with that. Apart from where do you put that right cache? I know it says cache on local hard drive, but most people will put that on SAN. Yeah? And if you're using PVS to optimize your I/O and take I/O away from your SAN and then you put your right cache on your SAN, that's not going to work either. Cache on device hard drive persisted. Well, you know I don't like PVS persistent, but okay, let's go for that one. Cache in device RAM. Now then, Citrix have made improvements to this over the years. Pre-PVS 5, it relied on a network driver to put the data in RAM. And the network driver answered the commit that that data had been written without looking to see that it had been written. So that means that the OS went on and said, yep, storage says that is definitely data, that is definitely there, you're all safe. And then when you came to get that back, it went, oh, no, sorry, lost it. Oh, you could put gigs and gigs and gigs of stuff into that write cache and it would always go in. And then when the OS asked for it back, it would blue screen. So it basically lost your data. Post PVS 5, this doesn't happen anymore. It only crashes your OS. Which is, I would say, an improvement, right? You don't lose any data, you just crash. I do know people who have done this successfully, though. You have to be very, very careful around your write cache sizing, though. It is very difficult to do. Not only because, you know, when you do your normal PVS cache, it separates your page file out. Where it doesn't separate your page file out here, it puts that in the caches as well. So that makes your sizing decisions around RAM even more interesting. Cache on server, well, we kind of all do that when we're first setting up PVS. Does it work? Cache on server, okay, fine, move on. Almost nobody does that in the real world. Thank goodness. Because it's a terrible idea putting the cache on server. We all know that, right? It's a really bad idea putting cache on server. Cache on server persisted. That's got to be the worst fucking idea I've ever heard in my life. I have no... Sorry? Worse than cache on SAN, yeah, much worse. So I have no idea why this is in the GUI, or at least I didn't have any idea. I got to talk to the MCS and PVS development team about 2 or 3 weeks ago, and I showed them the results of the testing that I'm going to show you guys in a little bit. And I asked them, why the hell is that there? And they went, it's always been there. This is the GUI. I don't care if you put esoteric options away from users, yeah, where you have to go and search them out and put them in. This is the GUI that people see every time they create a PVS farm. That should not be there. So, Project VLC very kindly allowed me to use some of their results. They did a kind of state of the nation thing. Johan, who was sitting out the back but had to run away, is going to present some of those results in another session. If you want to go and have a look, it's a great document as a big survey of what everybody's doing and what, so you can find out what your peers are doing, what common configurations, and et cetera, et cetera. So go and have a look at projectvlc.com. In that, they had a slide asking which provisioning method do you use for VDI, and there's all kinds of other stuff in here, like link clones or whatever. But PVS and MCS. Now bear in mind, this is not for XenApp, this is just for straight Zen desktop. And we can see that 75% of people use PVS for straight Zen desktop. And only 25% are using MCS. So why is this? Why is MCS the red-headed stepchild of delivery? Well, let's talk about MCS for a minute. MCS is virtual only. So if you have physical XenApp servers in Zen Desktop 7, you are still forced to use PVS. So MCS is virtual only. Citrix say it's for stateless and persistent. I don't agree. I say it's for stateless only. And it is simple. So you know I showed you the PVS architecture slide previously. So here is the MCS architecture. Why is that? If you have Zen Desktop, you have MCS, right? You can create an MCS catalog if you've installed Zen Desktop.
You still need the storage and stuff.
You still need the underlying storage, but you don't need a SQL Server or any of that stuff. Right. Pixie. This means is that it is inordinately simple to deploy MCS. So we'll have a quick talk about PVD. So it's a recent Ringcube acquisition, and it enables user-installed apps on a stateless desktop. Okay? You've got to bear in mind it makes everything persistent. So if you have PVD, then that stateless PVS or MCS machine that is attached to, that is now important to you. Previously, you could throw that away. You cannot throw that away anymore because the PVD attaches to that specific VM. You cannot take that PVD drive and move it to another VM and expect it to boot. It will not happen. So essentially, PVD is applied on boot and not upon login. This is something that many people don't understand. And I don't blame them because it sounds stupid. Because why would you want it to attach on boot? Well, the reason is that if you're going to integrate kernel-level drivers or other components that act at that level, then you need to apply the PVD image on boot. You cannot attach it on login. Now, I would actually prefer if they stopped people installing stuff that had a kernel-level component and applied it on login, as long as they could deal with the conflict resolution engine that they have and do that in a lazy way so you didn't impact your logon time. And then PVD would be more useful. Because at the moment, if you've got 3,000 users and 1,000 concurrent users, if you're using PVD, you have to have all 3,000 VMs up and running. Yeah? So it's very difficult to save stuff. Lots of people are talking about using it for UR. So I've run into a few sort of up to about 200 user deployments. Is anybody using PVD here? One at scale? No. How many users? 100 users. So that's about where I see PVD. Sorry, did you put your hand up, sir? No, okay. PVD is also unbelievably difficult to do DR with. And if you've got a persistent desktop, then I'm presuming that you want to do some kind of DR with it. And it's unbelievably difficult. Here's the PVD architecture side, sort of. I don't care about that. I'm not going to talk about that. Talk a little bit about link clones. So VMware View specific requires Composer, and Composer is in the most expensive license. Persistent is slightly more possible, but again, no storage vMotion for link clones. There's no other choice for View. There's no PVS versus MCS. You just got link clones. So this is again from the Citrix website. It's slightly outdated because it's actually talking about PVS and MCS in Zen Desktop 5.6 rather than Zen Desktop 7. But I prefer NFS storage because you can thin provision. Scalability. So used to say that MCS was for small deployments, but now you can do it up to thousands. 2,500. It says there I've heard 5,000. And anyway, if you put it as part of a pod architecture, then you should get less than that. So scalability, I think you can do it. You have sufficient IOPS available on shared storage. So unlike PVS, which provides a RAM cache for disk blocks, MCS directs more read activity to shared storage. So I got a bit of a kicking by Citrix Consulting Services about 18 months ago in Synergy. We did a CTPs versus CCS. And there was 3 guys from CCS. Nick Rintelen was up there. Is he? I know he's hit around this. Is he in the audience? No? Okay. And I stood up and said that I've deployed and used MCS very successfully in a lot of VDI deployments. And they laughed at me. Rather rude of them, I thought at the time. They said, well, MCS is much more IOPS than PVS. So, you know, VDI, IOPS, to keep them low, this is silly. All right, fair enough. We'll get onto that in just a second. So, in other environments, PVS is the right choice. You're looking at RDS or physical desktops. RDS is obviously not true anymore because you've got Zen Desktop 7. Your environment's IOPS trained, we touched on IOPS again, or NFS is not an option. You can do it on ICE, but NFS, they like, it's good for the thin provisioning. This is Dan Feller, who's also a CCS architecture. Here's decision tree for whether you should use PVS or MCS. He got all upset with me when I said I was using this, because he said, it's 2 years old. I'm like, well, tough shit. If you put MCS versus PVS into Google, this is what you come up with, so I'm showing it. So, what the hell? This should not exist either, right? This should not be a complicated decision for your architects or for your end users. This should not be a decision. Now, either this mixed color, which is MCS and PVS in the same architecture, wow, or it doesn't matter. So I'll come back to PVD. So PVD has a prerequisite for MCS and PVS, which are stateless solutions, but PVD adds some kind of persistent and then makes everything else persistent underneath it. The only advantage that PVD gives you is it allows you single image management in a persistent VM. That is it. So that means that compared to full fat, so full clones, which have well-known setup, very easy to support, you're using your existing desktop skills, you haven't got this kind of massive, strange architecture that is Citrix specific to cope with. Simple, easy to maintain, you can just use your existing skill sets in your organization. Performance, very performant. There is no filter drivers, there is no making up, pretending that you've got a single C drive out of your Golden Image and your difference drive and your PVD drive and you're smunging them all together to pretend to Windows that it's one single C drive. I don't believe that the added complexity of PVD is worth it for single image management in persistent desktops. I just don't. Steve?
Can I add something? I agree. But I think the problem with PVD extends into the fact that it's an unmanaged blob of crap. So if it was a managed, structured piece of data, you could move pieces in and out, you could do stuff with it, but it's just all your crap in a layer.
So,
you touched on this, but you didn't say it explicitly. It maps to a specific virtual machine.
yes.
Right, so it's like, that's crap. Not, you know.
So, Steve's point, for if you didn't hear it, was that the PVD is an unmanaged blob of crap, was your words? Yeah. And there's no sort of structured data to it. You can't look inside it very easily and troubleshoot it when it's doing the conflict resolution. And he also emphasized that if I didn't make this clear, it is specific to a single VM. Yeah, you cannot move that PVD drive out to another VM. So to get back to this large I/O overhead of MCS. So a blog post a couple of years ago by Ken Bell, one of the product managers, and he said that MCS was 1.6 times more I/O than PVS. And this is a bit weird, actually, because we know absolutely that PVS provides a static read cache, and VDI, we also know, is 80% write. So how can we get 1.6 times more I/O? That doesn't add up, right? It certainly doesn't in my head. So I decided to do some testing. So to emphasize what I'm talking about, so initially you get what I call reads, which is reads from your golden image. So reads from your PVS server or your MCS golden image. You have writes, and writes going into your difference file or your write cache. And you also have what I call rereads, which are reads from your differencing file. Yeah, so reads can actually come from two places. They can come from your golden image, or they can come from your differencing file. And writes will always go to your cache. Yeah, exactly. So testing architecture. Now you use the tools that you have to hand, right? I work for Atlantis, so I have as many Atlantis virtual appliances as I can lay my hands on. And essentially, what they do is I can create storage out of RAM. So it's unconstrained I/O, and I can have as many single points of storage that I want, and I can measure the I/O going into those single points of storage. So what I did was I set up 25 Windows 7 VMs, and we have a PVS server. I'm using BDM because I really, really hate Pixie. If you guys don't know about BDM or you don't use BDM, you should have a look at it. If you are doing PVS, it's excellent. So you can either boot off an ISO or a partition on the hard drive, and you can bypass the use of Pixie entirely. One of the problems with that, just to bear in mind, is that if you want to change the IP address, then you have to recreate your BDM from scratch. You can't change it on the fly, but just to bear in mind. So what I did was I measured the I/O underneath the PVS server, I measured the I/O underneath the write cache, and I measured the I/O underneath the BDM ISO file. I also measured the network throughput between the PVS server and the hosts. This is all on Hyper-V, by the way. So metrics gathered. So megabytes sent and received per second from the PVS server, PVS write cache reads and writes, BDM read and write, PVS server underneath the actual PVS server itself read and writes. Some of these we don't need. Megabyte received per second to the PVS server, so we don't care about traffic going back to the PVS server. Again, for the exact same reason, we don't care about writes I/O into the PVS server. And because BDM is also a read ISO, we don't care about writes to the ISO as well. So we can take out 3 of those. That leaves us with 5 metrics that we're actually looking at. I like graphs. It's not a proper presentation without a graph. So we got IOPS along the left-hand side up to 18,000, megabytes per second on the right-hand side up to 140 megabytes, and time along the bottom. Megabytes per second throughput. The theoretical limit of a 1 gig link is 128 megabytes per second. You will never see that in reality. You'll probably see somewhere between 90 and 100 megabytes per second on a 1 gig link. So, in effect, what we're doing is if you look at sort of this sort of 90 megabytes per second, that's a saturated 1 gig link. And I'm comparing throughput to IOPS here. All right? I believe there's some other IOPS session comparing throughput, and we'll have a look at that tomorrow. Can you compare throughput to IOPS? Is it a valid comparison? Does it tell us something useful? Well, I do know that a 1 gig link will be about 20,000 IOPS if you have a 4K block size. So in this case, you could do. Does Windows have a predictable block size of 4K? It does not. So this is a login VSI run, and I recorded the block size of every single I/O going down to storage. What we can see is we can see a massive peak at 4K. Right, so most of your IOPS are at a 4K block size. But we've got a very long tail coming down to the right-hand side. Now, block size in Windows 7 and Windows 8 is up to 1 megabyte. In Windows XP, block size is up to 64K. Do you know something very, very sad? I can look at the block size of a Windows OS and tell you what OS it is. It's really bad. I know. So we do know that most of our IOPS are at 4K. So can we just say, right, well, let's do that calculation. Let's divide our throughput by 4K. That gives an approximate number of IOPS. There we go. This is throughput. We can see at 4K, we've still got a peak, but we've got massive peaks right at the very right-hand side. And that's because the difference in size of these half a meg and 1 meg blocks completely outweigh the massive amount of I/O at 4K block size. So this means that can you divide throughput and change it to IOPS and make a comparison? In the real world, no, you absolutely can't, because this variable block size. Have I done it? Yes. I picked it's like 8.5K. It seems to work, but just because I know this stuff really, really well. I wouldn't advise using that in any other situation. So now we know what we're measuring, how it's comparable. So let's have a look at the actual results. So this is PVS. And
is this the metrics combined?
Yeah, so we'll show it. I'll go through one by one. This keeps failing. So first off, reads from your BDM ISO. 0. That is because, actually it's vSphere, not Hyper-V I used, my apologies. That is because vSphere is caching the BDM. So there's no reads from your BDM ISO. So there is a myth that you need to have very high read throughput underneath the BDM ISO. You don't, not if you're using vSphere, because vSphere will cache it. So this is megabytes sent. So this is throughput. So remember I said that about 90 megabytes per second is a 1 gig link. So 25 VMs booting is actually saturating a 1 gig link. That's interesting to note. So it's switched on at this left-hand peak. I just realized that I'm putting lights on here, but you guys are watching that one, right? Sorry about that. So it's switched on at this left-hand peak, and then this kind of bottleneck here. I didn't know what that was. I thought, I'll be kind, I'll not blame it on PVS. I thought it might be in my environment. I didn't have time to really go into it and troubleshoot it. And as I say, I went to talk to the developers the other week. And they said it's when you change the NIC from outside the pre-boot environment into Windows. As soon as the Windows NIC take over, the throughput is massive. So the Windows NIC takes over here, and you get this classic double read peak. A double read peak is really classic for a Windows 7 boot. So what we're seeing is that it's pretty expected, right, apart from this weird sort of bottleneck at the start, is that we're getting a massive amount of read traffic over the network when we boot PVS VMs. So reads from underneath the PVS server, 0. PVS is doing an excellent job of keeping the golden image in RAM and serving out all of those IOs from the RAM on the PVS server. You've got to size it right, obviously, but if you do, it does a very, very good job of taking all these read IOs away from your underlying storage. Write cache reads, or the rereads I was talking about, very small, very small. I was expecting more here, but there's hardly any. I'll maybe do another BriForum session on this, but that brings up the question, if you're not reading back the data that you're writing into the write cache, what is the data that's going into it? I know a lot of it's Windows doing stuff and NTFS doing stuff underneath, but still, you're not using that data, you're not reading it back. Anyway, Write cache writes. So these are writes into the differential file, and we can see it again classic. So you get your double read peak for Windows booting, and then this lower write peak going into cache on local hard drive as this is. So this is actually an IOPS, not throughput. So we're actually peaking here on write on boot, and boot is a massive read operation to about 6,000 IOPS. That's kind of interesting as well, because write is hard to cope with. So this very, very good read cache that PVS is providing out of RAM, and this gets, I hear this all the time, PVS is good at caching. Your I/O comes from RAM, you're saving yourself loads of storage by using PVS. Anybody got a SAN in their environment? A few people, yeah? You've got a read cache. Yeah? You've got a RAID card, you've got a read cache. There's a read cache on most hard drives. Read caches are very, very easy to provide, and they are all over your infrastructure. PVS has a very complex way of providing something that is pretty much all over your infrastructure. So that's PVS. So we'll look at MCS. Again, 25 Windows 7 VMs, booted them simultaneously. Obviously, MCS is much, much simpler. Now, it copies the golden image to every bit of storage. Now, this is really important to remember when you're using MCS. You cannot have a centralized golden image when you're using MCS. This becomes a problem if you're using some kind of storage acceleration, whether you're using SSD or things like that, because instead of price per IOP being high, your price per gig is high. So if you have many images, so if you have 6 or 7 images, and MCS is copying all of those images all around your infrastructure, and not only that, when you update it, it copies a second one across and then deletes the first, so you've got to have space for 2 of each, then you can get into real problems with space with MCS. But just something to bear in mind if you're using MCS. Like I say, very much simpler, because the golden image is on the same bit of storage as the difference files, because that's where MCS puts it every time. We're measuring I/O at that point. So we can see we've got our double read peak again, and the smaller write peak coming at the end of the boot. And so the write peak is peaking about the same as we were in PVS, so the writes are pretty much equal at this point. And we can see the read peak is coming from the storage this time, it's not coming over the network. So effectively, on boot, PVS is saving you everything under this blue graph. So it's actually quite a bit that it's doing, saving you a good amount of reads. Overall VDI is 80% write, so this is just a graph from RefStock that I did a while ago. Another VSI run. So reads are stacked on top of write, so it's just showing you that VDI, as we know, is 80% write. Now, writes into the write cache for PVS at the top. Average, so I forgot to tell you a little bit, my mistake. This is not boot anymore. This is steady state. So steady state I define as after boot, after login, after applications are open. So you've got your day-to-day sort of usage. And how I created this was, so a login VSI cycle is 12 minutes. I'll make sure that the cycle will run at least once on every single VM. So every single application has been opened at least once. So we've got all the applications are cached in memory. So this is the exact opposite of your boot. So the 2 ends of the spectrum I've tried to concentrate on here. So this is your steady state I/O. And this is the most write-heavy time of a desktop's life cycle. So that's interesting to note, actually, because the more time you spend in steady state, the more your write I/O builds up. The only time I've heard of sort of, getting onto 50% read is when somebody's, like in education, if they're logging in and opening applications again and again and again. So in a kiosk mode, so there's lots of people. So, average, very similar, 128 for PVS, 139 for your MCS write cache. Very similar. Standard deviation. Now this is much more important than average. Standard deviation tells you how bursty your workload is. Really crucial in a desktop. If you cannot burst, you do not have any user experience. So the burstiness of your workload is really important. So, and we can measure that by doing standard deviation. 73, 72, almost exactly the same. And peaks at 457 and 491, so very similar as well. So writes into the differential file, very similar. Now there's slightly more for MCS, but overall, very similar. So reads. Now, reads from the write cache, or the rereads, very small. PVS network send, quite small, and MCS reads. So that's obvious, right? Because we're reading over the network from the PVS server. So that's, again, expected results. Standard deviation. So for the throughput, the network throughput, we can see the standard deviation is twice the mean, which effectively means that when you translate your I/O over the network, you're getting a much more bursty workload. So be very careful of that when you're doing PVS over the network, because it actually makes it even more bursty than I/O is normally. So it's harder to cope with. Whereas MCS read is standard deviation, same as the mean. So not as bad as the burstiness of the PVS over the network. And write cache free, so very low for PVS, and again high for MCS because of the obvious network thing that we talked about earlier. So what does this mean for our 1.6 times IOPS for MCS? Well, in steady state, and this is the state that users spend 99% of their time in, and the bit that we care about, MCS is 8% worse on write. And write's the bit you care about, write's the hard bit. So MCS is only 8% worse on write. And even if you include the read offload of PVS, it's only 20% worse in total. 21% worse in total.
But that's a lot of load in a big SAN, right? So if you take all that read off of a large SAN that's busy writing,
so
it is an effect.
So Steve's saying that even though the 21% is lower than the 1.6x times we talked about before, it's still, in a large enterprise, a large thing for a SAN to have to cope with all of that I/O. Apart from the fact that your SAN has a read cache. Yeah?
But a lot of SANs are arbitrarily shared controllers, right? So the central backbone has to do that work. I'm not judging it, I'm just saying that load is on the SAN. That load is on the SAN. You haven't pixied it off to your PVS server, right? Or your network. So the excess I/O load of MCS, I would say, is pretty over-egged. And if you think about it hard, you're getting exactly as expected behavior. PVS is providing a static read cache. Yeah, and all you're seeing is the effect of a static read cache. And that's quite predictable once you know how Windows I/O works. If you think I'm madly disagreeing with Citrix here, I'm actually not. So CCS have come around much more to MCS than they were when they were laughing 18 months ago. So they're much, much happier with MCS than they were. And I talked to the desktop product managers of MCS and PVS, and they agree with my testing. So although 18 months ago we were in very much a different camp, it's not really the same anymore. People keep asking me this, is PVS dead? Well, it will be at some stage, yeah? I mean, it's using a physical paradigm to provide what is natively available in the hypervisors now. Now, is MCS on feature parity with PVS? No, it's not. It doesn't have the image management stuff and other little bells and whistles, so it's not on feature parity. It copies all of these golden images to every single bit of storage. You do not get a choice to host that golden image centrally, but this will change over time. Having said that,
in a way, PVS will never die because the functions that you like in PVS will be moved into MCS. So at some stage, you will have feature parity and you will not need to use all of that infrastructure. I believe that that will be the way that things happen, but it's going to take us a long time. So for instance, PVS was released with Zendesk 7, so it will be supported at least until end of life of Zendesk 7. That's a number of years away, so we're talking 5, 6, 7 years away. I actually looked for the end of life of Zendesk 7 on the Citrix website today, but they've not published it yet. It's not on their product support metrics yet. Also, it's just got a big update, PVS 7. It now supports SQL Server 2012, System Center 2012, Windows 8 as a target, and 2012 as the PVS Server itself. Yeah, they've made another nice change to it. Now, you don't have to go to another application to create your BDM file. Your BDM file is now natively within PVS, eliminating the need to use Pixie. And it automatically formats your local hard drive cache. All excellent changes and shows that the PVS is actually still being actively worked on. But internally, I know that in Citrix, people set up using MCS. Also, for Hyper-V, provisioning services now automatically switches from the legacy NIC to the synthetic NIC. Really good change. So you Pixie boot with your legacy NIC, and it switches to your synthetic NIC afterwards. Also a good change.
That's actually going away in R2.
Is that going away in R2? Wow.
You'll be able to Pixie from a synthetic in R2.
Oh, that's even better. So if you Pixie from a synthetic in R2, even better. You don't have to do that actual change. MCS new features. KMS support. Well, there was a KB article that said you could do KMS. One thing to also remember with MCS is you can't do Mac for licensing. So, conclusions. Unless you have a very, very specific need, do not use MCS, PVS, or PVD for a persistent VM. Full clones. You'll thank me for it in the long term. If all of your XenApp servers will be virtual, MCS is more than valid for deployment. In fact, I would say that MCS should be your first choice and PVS to fall back on when you need the features, because it really is that much simpler. And as we showed before, automate the build of your gold image. I don't care which one you're using, but you must automate the build of your gold image. Have we got any questions on all of that, guys, on the testing methodology, on anything else?
Well, on the last statement, I guess I hear you saying don't ever use PVD, because if you're not going to use, the only use for PVD is to provide persistent VM or persistent experience. So you're saying PVD is dead.
I'm saying that without changes to the PVD architecture, its use case is very limited. I'm not saying it's dead, but
Nobody uses it. Nobody,
yeah.
It can be very, very challenging.
So
I've dealt with it. I refuse to use it. When customers
But like everything else, there's a case for it. So there may be a case where you need that situation and you don't really care if you lose it.
so if you don't care if you lose it, yeah, why persistent? Yeah. No, there is use case for persistent and no HA, there is, yes. So there are also scalability issues with PVD and performance issues.
What about we haven't spoken about this debate about where to host either MCS or PVS channel to use local SSD on the host.
So I don't believe that your difference file, which is something for PVS or MCS. So sorry guys, the question was, I didn't address the debate as to where to put your difference file, whether to put it on shared storage or to put it on local SSD. Shared storage is made for capacity and redundancy. These difference files are, by definition, transient data. You do not save them, you literally throw them away. So using a solution that's designed for capacity and redundancy for these high-cost transient data, I don't think is a good idea. So I'd much rather use a local on-host solution. I can't speak to Unidesk. I haven't tested extensively, so I'm not going to go into that. If you want to speak to Unidesk about that, then please go ahead. But I can't pretend to have knowledge where I don't, I'm afraid. Any other questions?
So if you have a diverse set of users and a diverse set of apps, so are you recommending that dedicated VDI?
Yeah. So I like persistent VDI if you can get it right, because it's simple. Users don't like a shared experience, yeah, because you're locking down the OS, or you're separating out the apps and the profiles and stuff. I have nothing against any of these technologies; they work well, and if you put them in right, then great. But then you've got to support and architect it. A full-fat persistent VM is easy. Now, I'm not saying that persistent VDI is correct for every use case. Absolutely not. But I'm saying that instead of automatically thinking, I must do stateless, now you should think about, well, actually, would this be easier to achieve? Would I get the right result if I'm doing persistent instead?
There's no other solution as far as just hiding up all the resources, say, users will use it a portion of the day. Those machines are on taking up all the resources. They're just allocated to that VM.
So you could do floating persistent. You don't have to assign the users that VM. You can still get your concurrency. You don't have to have a one-to-one mapping between that user and that persistent desktop. Any other questions? Steve?
How much of this problem is created by Windows OS behavior, writing stuff to disk all the time? Do you think those basic operations are essential, or is it excessive?
So a lot of the operations that Windows does that creates these IOs, a lot of them are essential NTFS doing stuff, right? It's doing sector level optimizations so that it rejigs stuff for a local spinning drive. A lot of it comes from NTFS. So at some stage, yes, these aren't stuff that really need to be done in a virtual world, but they're not going away anytime soon because NTFS isn't going to get re-architected the way Windows isn't going to get re-architected. So in an ideal world, no, it shouldn't be doing all this stuff in a virtual desktop, but we can't do anything about it, right?
I'm wondering if that applies to SSD in general. Like a lot of this behavior comes from trying to milk the most you can out of a spinning disk and a little bit of RAM.
So now you can enable trim and all that kind of stuff in Windows for SSD, and that changes the behavior underneath to a certain degree. Whether that helps in a virtual desktop environment, I'm not sure. I need to do some more research on that. Yeah. Yep. Sorry, can you speak up slightly?
Some of the storage vendors there are trying to accommodate that model for who it's in like injection. So it's not really full anymore. So it's a lot thinner than what it used to be. And do you know of any development side MCS as far as control of where those like the golden image copies
Yeah.
are placed across instead of this?
So I don't know about the internal Citrix roadmap for MCS. I would say, in my own opinion, that it would be unwise of them not to be working on that. And your other question was, there are companies around that do inline DG which can handle persistent VMs. I work for Atlantis Computing. I'm not going to say anything more about that in this session. I think we're almost done, so last question, if you guys have got one. Nope? All right. Well, thank you very much for coming, guys, and have a great rest of BriForum.